first speaker today, Riveros Escobar.
Look. Yeah. Okay. Cool. Not too much. Okay, perfect. So, thank you very much. Thank you for being here. Yeah, as Ralph said, yeah, it was tough, I think, for yesterday for the party. But yeah, I mean, this topic is really a topic that I'm really interested in. It's the cognitive bias being discriminated by an algorithm. I'm Francisco Riveros, Watson technical lead working at IBM. So, and before that, I would like to tell you a little story. So, this is my friend Carol. Carol is a proud mother, which has which wanted to go into the labor market, and she told me that she wanted to have a position, project manager in Amazon, a big company. So she wanted to apply, and I said, well, you have a really good qualifications, you have a really good experience, great grades, so yeah, why not? So you should apply. So she started to apply, she started to looking forward for interviews, and what happened that 2 months later, I met her for a coffee, and I asked her why, I mean, how was the recruitment process go? And she was really sad because she told me that she was rejected automatically, or just she sent it and received an email that she was rejected. So it was quite weird because we said that you have a really good qualification, good experience, and I think you were the best for the position. And so the next day, I was in my daily routine, just checking the news and the newspaper, and I saw a news that Amazon was scrapping with a secret AI tool that showed bias against women. So I told my friend that maybe that's because she was rejected, and we started to see why. So the reason is that the algorithm behind the program or the computer model were trained to vet applicants that were observing patterns in resume observed for a 10-year period, based on the dominance of the males in the industry. So, so the company system taught itself to penalize resumes with patterns with the word women. And also, if you have in your resume that you are from Women's Chess Club, was penalizing against that. So as you see, this is quite interesting, quite yeah, disturbing for these kind of things. So yeah, the thing is, I don't have a friend Carol, but this could happen to someone because this actually was revealed last year, and that shows us that how an algorithm or something like really invisible can discriminate people. So besides that, I would like to explain you other examples that, of discrimination for algorithm. This is the photo classification software for Google. As you know, you have tons of pictures and your cell phone, and Google wants to classify automatically. So the algorithm for Google classify, as you see, in a wrong way. There is another example. I heard a lot of this example yesterday. Besides this adaptive chatbot, was created for Microsoft in around 2016, and was designed to tweet and engage people in other social media. So that was like they wanted a chatbot that speak like a teenager, but someone figured out to tell bad things, inappropriate things. So you can see that it's really was disconnected 24 hours after release. The next example that is really interesting is called recidivism assessment. Is about what is the likely that you are going to be arrested in the future. This is online. I mean, this is working in US in the judge. So if you are a judge, you are in front of the system, the person, and the system said, okay, you are going to. How is it likely that you are going to be arrested in the future? Yes or no? And yeah, and if it's low probability, low risk, the judge can let you go. But what happens is that ProPublica, which is a press research, they figured out that they made an analysis that for black people it's more likely to be wrong in a bad way. So as you can see, we are here. We say that the algorithm itself is not the fault of the algorithm. The fault is the people, of the humans that are behind of that, because it's the human that train and test the algorithm and choose the data to train these algorithms. So we have to understand that there are human factors that begin the process, and this is real. So the other concept that we have to take care when we are talking about this is the concept of garbage in, garbage out. In machine learning, algorithms are very dependent on how accurate, clean, and well trained or well labeled the trained data. So they can produce accurate results. But so it's not wonder if you train your machine learning algorithm with garbage, it's not surprised that you are going to have garbage out. So this is as in the cartoons, as you see here, the cartoon said that the concept in the fairness concept was not really talked in the past, but now it's one of the hottest topics on the machine learning and AI research community. But maybe you are wondering what is fairness, or how we can classify what fairness. The thing is, there is no one definition of fairness applicable in all the contexts. There is a really great tutorial for a professor of Princeton in YouTube in this link, where you can check how the various ways where you could measure fairness. But yeah, there are some definitions that even get in conflict, and it's really difficult to define. So the good news is that the community is aware of the problem. They try to measure, but it's not yet clear how what is the right way to do it. So because social justice and philosophy behind and all the other stuff. So we can say that bias mitigation is not easy. This is an example of how it's turned out that we have, when we are learning something, we can say that the attributes, like sensitive attributes like race or sex, we can just delete it from our training data. But in the real, that maybe it's not so easy, because some attributes that you are using are correlated with others. So, for example, in this famous case of Brooklyn, New York, some people feel like the zip code was a non-sensitive data, and they started to do the model against this. But they didn't realize that the zip code was correlated with other things. So I think I'm really fast. So in conclusions, trust is really crucial for the wide-scale AI adoption under 4 pillars, like fairness, explainability, robustness, and auditability. there is a lot of technical innovation in bias detection and mitigation, but there is really hard questions that need to be answered, like which metrics should we use, or how we can, what is the trade-off between fairness and accuracy. Bias detection and mitigation, we can create tools to assist people to find those problems, but you really need that the stakeholders take the decision or make the call, because there are really important decisions behind that. And as you can say that this field is not really about machine learning or software engineering. It's more like a lot of philosophical questions, a lot of public law, public policy, law, social science involved. So it's not really it's really hard topic right now. And as last point, IBM Research in AI is working on all of these above points and other players in the industry. And I think as the last point, last point, I encourage you to think about how we can build a trusted and transparent AI. Thank you.
Thank you very much for this interesting insights. Now, as usual, it's your time. Since we are just a few people, you can't hide. So, are there any questions from your side? I will go around. There are no wrong questions.
So what are your first answers in solving the problem? Because now you described the problem, and I think it's understandable, but also very scary. And
yeah,
but I'm sure you already have some answers to that.
I mean, as I said, we are in the community, or the research community is aware of the problem. There is a lot of, I mean, from all the players, they are doing, because they realize that we cannot live with that without someone or some software, piece of software that help us to find these problems and try to mitigate them. So we have, for example, in IBM, I can tell for IBM that we have something like it's called OpenScale, which is a platform where you can analyze your models and see how fair it is. And they offer, we offer in the platform the various ways how to mitigate that. And there is the platform OpenScale is for the business user, but we have another platform for developers, where the developers of data science persons can check, okay, this model is working in this way, so the platform say, like, I recommend you to go in with this model to go and mitigate that bias, because you have a bias here, for example, in race or sex, you know. And there is a lot of, I mean, every time what we are developing something to get this done. Also, there is an initiative that I can show you here that why we cannot do the transporting report, like as you can see that we have nutrition facts or all the other symbols that we use in our common life. Why they don't have a mechanism of trust? In IBM we call it like fact sheets, where you can say why this algorithm is intended to use, what algorithm of techniques are implemented, etc.
So a label for AI, so trustworthy, not trustworthy, has a bias, has no bias.
I mean, it's more like, I mean, you as a developer or a data science, you don't say like my algorithm is biased.
Of course not.
The intention is that you try that your algorithm it will not be a bias, not be biased itself. So that's the way that we can say for not do it, or to try to not have this problem.
Would it help them maybe to include those people who are now excluded because of the biases into the development of AI? So include more women, include people from different races. Would that help?
I mean, there is a lot of techniques that you can do in itself. One is discriminated mitigation, that you also do this kind of stuff. I mean, there's a lot of techniques that you can do it. Yeah.
Other questions? Doesn't hurt.
Francesco, thinking about the next level of intelligence, when we just try to extrapolate what is going on, then my assumption is there will be in some days or weeks or months or years a software which reproduces itself, so that you don't have to build all these algorithms anymore, but a real self-learning world, self-developing algorithms, and so on and so on. And so the obvious threat, so the dark position, it's still there, because there's always someone, everyone is biased. There is no individual in the world that is not biased, and whoever is the one who sets something like that off will also dominate whoever uses it with all the things he has put into this world. And when I see many kind of big startups, the Facebook world, for example, it's like a sect. Yeah, it's they all share this wonderful, fabulous vision of a brave world, but only their vision of a brave world. So there are even people who are really convinced that they are doing the right thing, but maybe not doing the right thing at all. So any ideas how we as humankind somehow get a better hand on control of this kind of systematic which may lie behind this whole coding stuff here?
Yeah, I mean, it's a really interesting question. I think, as I said, it's a lot of philosophy and ethics behind this. But from my perspective, what I will recommend is to start, like for child to start to teach them what is an algorithm, what can do, and what AI is capable to do, and because they are our children that in the future they are going to handle with that type of things. And these are the people our children is that they are going to be data sciences, or maybe that will handle these problems or will have these problems. But it's really difficult to find a way just to say how to fix it. There are a lot of things that going on, regulations. The industry is regulating itself, but yeah, it's really hard. It's really hard and philosophical.
I think the first step is already made to identify the problem and now develop solutions. Thank you very much for your very interesting talk.